go. So as usual, we will be starting with yesterday's homework. So exercise 5 was illustrate the situation in example 1 on page 4. I don't know if I pointed it out. You guys know that the table of contents is hyperlinked?
Yeah, you click it and it takes the right.
So are all the references. Example 1 on page 4, we click on it, and there's example 1 on page 4. So, okay. So this one, you're just diagramming it. I heard people suggest yesterday that's a tree diagram, and that's probably the best way to do it. Yeah, but you've had plenty of time to get it already, Alan. So get it quickly, but you've got to be in the habit of having all your afternoon materials with you at the start of the day. Alright. So yeah, you can draw it with the tree diagram, so 5 shirts, 4 pants, right, 3 purses, and a whole bunch of lines. That's the basic way to do that. Now, exercise 6. A student is sent to the library to get a book. 10 westerns, 12 fantasy, and 42 R.L. Stine novels. How many ways can they return with a single book? So Frank says it's an or problem. Right? You can have 10 westerns, or 12 fantasy, or 42 R.L. Stine, because you're only picking one book. So 10 plus 12 plus 42 makes 64. Joe claims he solved the problem without using any conjunctions. Well, you could do that just by adding them. I'm not saying it's add or, saying they're only getting one book. So the way they categorize it doesn't matter. The categories here are irrelevant. There's 64 books to pick from, and the student's coming back with one of them. Chet got 5,040 for the answer because Chet multiplied them all together and treated it as one Western and one fantasy and one R.L. Stine to bring back 3 books when it's really just one total. So there's 5,040 ways to pick one from each category, but they were looking for one total, so Chet got the answer wrong. Yeah?
Frank thought it was at 1 box, so did you do like 64 factorial over 64 minus 1 factorial?
No, that's the or problem is when you're adding up your choices. So he said, well, there's 10 ways to pick a Western, or you could do 12 ways to pick a fantasy, or 42 ways to pick R.L. Stine. 10 plus 12 plus 42 is 64.
So they both added them, Frank and Joe?
Yeah, it's just kind of, for them it's a difference in mindset. And then Frank and Joe both had different approaches that both work. It was Chet with his 5,040 that was incorrect.
You're asked to pick one book, right? So you would add them because you just want one book, not all of them.
Right. Yeah, that's why. And I see Jarvan's question, so I didn't talk about it, but the one where you're illustrating, you've got 5 shirts to pick from. So these are t-shirts because that's something that my artistic skills can mostly keep up with. You'd have 2 more. You'll have, I think it was 4 pairs of pants. That one's got a horrible pant leg, so you don't wear those. Yeah. Well, yeah, bell bottoms would be like. Okay. And then I think there was 3 purses, right?
Yeah. There's 5.
There's 5. I just did the tags. So you could draw the setup this way, and then you'd have, you could draw your lines from each of these. And lines here. So you end up with a whole bunch of lines with this basic drawing. So that would be how you would illustrate number 1. And now to turn the questions back on. So number 8, define permutations in your own words. So the permutations are a way to figure out the number of ways to arrange a given group of objects when order matters. Exercise 9. So which can be solved with permutations and which cannot? So, determine the number of possible ways to fill a committee of 5 people with 5 different positions.
Yes.
Yep, so that's 5p5, which is a permutation. So yeah, it's 120. Determine the number of possible ways to fill a committee of 5 people that have 3 different positions.
5
Yeah, you could do that as 5p3, which would be,
60.
what, 60? Yeah, because that's everything but the times 2 times 1. The number of possible ways to watch every episode of Gilligan's Island. You have to watch the pilot first. The next 98 you can watch in any order. That's, yeah, 98 factorial or 98p98.
I thought Aaron put it up.
It's too big.
Yeah, it's more than your calculator can handle. Most calculators, they start choking at 70 factorial. So you don't have to come up with the actual number. You can just write 98 factorial, and I would accept that.
Well, because I thought it was wrong because it was like
Wait, how do you do that again?
So for that one, you've got 98 episodes that could theoretically be watched in any order. I suppose we could break it down because the first season is black and white and the rest is color, so it would seem weird jumping back and forth. But the ultimate there is 98 factorial, and that's what I'm looking for, so you don't have to try to do the calculation, because 70 factorial is the first factorial that most calculators choke on, because that's the one that's more than 9.9 times 10 to the 99. If you have one of the HP graphing calculators, you could do more than that, because they go up to plus or minus 499 instead of just 99 for their exponents. But the TIs that are approved for schools choke at plus or minus 10 to the 99.
Okay. What answer did we get for that?
You just leave it as 98 factorial.
Okay.
And number 4 in exercise 9, a movie theater with exceptional taste plans to run a marathon of Disney's Goofy shorts. So those are the 7-minute Goofy cartoons. There are 49 such shorts, but they're only going to have time to play 17 of them. So how many different possible ways can they show 17 of these 49 shorts?
49
Yep, 49 permute 17.
It's the same way with the setup.
Yeah, it's a similar idea. So the 49p17 will come out to
It's like
about 2.3 times 10 to the 27. So again, lots of options. Or you can just go to eBay, get the complete Goofy and the Walt Disney Treasures DVDs, pop it in and hit play all.
Mr. Dollar, do you know the permutation of the combination function in the calculator? I forgot.
Yep, you hit math, and then you've got a list of menus there. You want to go over to the PRB menu, which is the 4th one, and then NPR and CRN factorial, I think, are options 2, 3, and 4.
Okay, got this. Thank you.
And then the last homework question, exercise 10. Little League sports teams often have players change position, so everyone gets a turn in every part of the field. You've got a sport with 15 players and 11 positions. How many possible permutations are there?
15.
Yeah. Yeah, it is 15p11. So
It's
it's-
the third one of permutation. Or exercise 9.
Yeah,
So they're all.
they're all permutations. So 15p11 is going to be the same as 15 factorial over 4 factorial, or roughly 5.4 times 10 to the 10. So we're looking at about 54 billion ways for a Little League team to be filled out. So you are unlikely to get through all possible combinations in one season. You need to have a very, very long season. So, are there any questions about any of these?
No.
No, and just to respond to the chat, yeah. Most of the numbers in the permutations section are going to come out much larger than we are used to working with. Because there's just...
So you learned that like for 15 permutation 11, and the answer is like decimals 2 times 10 to the 10. So do you write like all of it with the decimals?
For that, because we do prefer the exact values, I would even just be looking for 15p11.
Okay. That works. Thank you.
Because I think it's safe to assume that students who've reached this point, if you can get to the 15p11 part, you can pick up the calculator and finish it. If you've got a hard time doing that, you're probably not in 30-1. So now, the new content, we are dealing with combinations. So these are very similar to permutations, except, yes, exactly, order does not matter this time around. Which makes the numbers smaller and more recognizable. It also means that when we're doing our calculations, we are more likely to get the exact values because we are dividing by an extra factorial in the original definition. So, for example, you're packing for a trip. You're going to be going to the mountains where there's poor cell coverage, so you don't want to depend on a streaming service. You decide to bring some CDs with you. If you own 37 CDs and your carrier can hold 12, how many possible combinations of music can you bring? Right, you could have, if you have 12 CDs, there's 12 factorial ways to load them in the carrier, but anytime you want to feel like a given song, you can play that given song because it's on one of those CDs. So that's what we care about, just which songs are on the list. So we don't want to just have that 37p12. Because 37p12 is saying, okay, this is how many different ways we can pack 12 CDs, but that's where order matters in the way we load them in the carrier, and we don't care about the order. So what we do is we take that 37 factorial over 25 factorial, and we divide it by the 12 factorial. Because we've got the 12 objects, if we don't care how order matters, 12 factorial is the number of ways we can arrange those 12 CDs we've chosen. So that's why we end up dividing by the 12 factorial, which gets us down to 1.9 billion. It's still a lot of options. So the numbers are not small, but they are smaller than the permutations. Right, this is about 1.8 times 10 to the 9 compared to 8.87 times 10 to the 17. So generally speaking, the difference between them is dividing by that extra r factorial. And that is really the fundamental difference between them. That's right. If you can handle the permutations, you can generally also handle the combinations. So, from here, partly because I knew our physics class would run long, we haven't had a chance to do the physics homework. And because combinations are review, right, we've just got that one example. So we will have 3 homework assignments today. 1.03 number 1, 1.02 number 2, 1.01 number 3. So I'll get people to copy some of these down, and then we can do the physics and math homework for the rest of the class. We don't need a whole lot of class time for this today. So we'll start with that 1.01 number 3. Well, you're just going to have time to do the math and physics homework today. No, we're still spreading out the 1.03 assignments. So the 3 assignments we're doing are the 1.03 number 1, 1.02 number 2, and 1.01 number 3, just like usual. And actually, I'm going to quickly stop the recording.